this section that we'll be doing in the workshops that we've done over the years as well, especially about graphs and other multimedia stuff, have been about how we can best present our graphs, especially the data that we get. Generally, what we see in other groups is that people take screenshots. So especially the organic group, I know they're not here, so at least no one is going to murder me for that. When they do IR, they'll do it on the instrument, and then they'll just take a screenshot of what they did. And what we generally do in our group is that we take the X and Y plots and we replot everything. So in terms of what we do in the group, that's what we expect, that we replot instead of just taking screenshots. Because the more you replot the data, the better you actually understand the data and what is happening with the data, and you can interrogate it a little bit further. So in the next hour or so, that's what we'll be dealing with, just graphs. And generally, we know that a picture is worth 1,000 words. So the graphs are actually telling a story. When we started the workshop, we spoke about how narrating the story that we're trying to tell in our research is quite important. So this also forms part of an integral part of what we are doing. So what I'll take us through, just as an intro, are the 5 W's and the 1 H of the graphs and multimedia, just so that we can unpack the importance of us actually having good graphs and why we need graphs and other multimedia as well. Okay, so the first bit is, what are graphs or the multimedia? So I'll just refer to graphs, but it refers to both. They're visual representation of data used to explain and enhance understanding of complex concepts or data. So generally what the graphs would do, they would summarize the information that we have, highlight trends, patterns, or some kind of relationships, or even support arguments or hypotheses. So it's quite important for us to use them specifically for what we're trying to do, and not just have a graph for the sake of having a graph at the end of the day. Some of the graphs that we can have are your histograms, Staffel plots, cyclic logograms, etc. With images, can be videos, it can be all kinds of images that we have. So what I wanted to put up as well is part of the work that I did in my MSc. And the reason I put this up is, in my MSc, I came across a different way to isolate isomers. So these are psilocybin isomers. And from what is known about psilocybin isomers is that they can only be isolated using HPLC. So obviously when you're doing your master's, you're still very fresh in the field of postgrad, you're still trying your luck, etc. But what I was told when I started, and I think it goes back to what Zakes was saying yesterday in terms of that color. You know, we're always looking for a certain color. We know with quantum dots, if you get black or any nanoparticles, then you know you have the color. So that's a similar thing that was happening at the university that I was in before that. I was told that when I purify my samples, I had a big sample of the psilocybin material, I mustn't pay attention to the other aliquots that will come. I must pay attention to the last aliquot, because that's the material I'm looking for, essentially. Because the material was Lewis green, he said, in color. But as I was there doing my MSc, I was collecting everything. I was like, oh, we'll see. I mean, it all looks nice, so I might as well just collect it. And when I was collecting, I also wasn't aware, because remember I was told that I must just pay attention to the last aliquot, and that's an aliquot we kept on analyzing. But as I continued with the material, what I noticed okay, it's not that clear here, but these were like different colors, like this was a dark blue, and then it became lighter, but the shades were different, and I thought maybe there's something that we are not noticing with these. So let's analyze them even further. So when I analyzed them, I did some mass spec on them and other kinds of analysis just to prove what was happening in those aliquots, only to find that I was actually isolating different isomers. So when I was presenting my work within the school, I remember Professor Nyogong was like, it's impossible. You can't be telling us that you've isolated isomers, because all they've ever known is that they can only be isolated with HPLC. So when I came and I was presenting very confident, saying, I've made a discovery. I have isolated isomers using column chromatography, the most simplest method ever. There was a lot of arguments that were put forth for me. They were like, no, it's impossible. And at the time, I wasn't taking any of these pictures. I was just telling them, these are the isomers I had, because I was able to distinguish the isomers, and that's what I said. But one thing that came to my mind was, maybe I should then take pictures of what I was doing as evidence, because as scientists, that's all we ever want, evidence. Show us why, show us why. And that's when I was starting to take pictures, and when I was presenting, those are the pictures I was then trying to show in order to do what I said here, support my argument and the hypothesis I was putting forth that column chromatography can work in this instance based on the method that I was using, and that's what I put forth. So what I wanted to highlight here is, in terms of why we put out certain graphs, certain images, etc., is telling a story. So once you have the evidence and once you can prove it, then no one can tell you otherwise as well. But it was also quite important for me that in my write-ups as well, to put the same images as well, just to support whoever's going to be reviewing, because I'm sure they will also say, HPLC has been proven to do this, you doing it by column chromatography, prove it, you know? So that's why we can then use some images in order to support our claims. Who uses graphs and various multimedia? Anyone who wants to communicate information in a condensed format. Because obviously, when I thought of my MSc and how I had to go into detail about how I did the study in terms of isolating those isomers, the images were just like the summarized version of what I was saying in the text. So that's why I then use those graphs. And basically researchers, students, educators, even people in other fields like data analysts, statisticians, science communicators as well. And I think it's quite important for us to then use these graphs in order to communicate even with the broader audience. Half of the time we make such great discoveries and they can be in our jargon, right? But if we put it in a picture form, it then simplifies the jargon into something that someone, even your grandparent, can then understand that, oh, this is blue, this is green. Once it turns green, it's a good sign or it's a bad sign. And it's a quick way to then summarize what we are doing. When can we use these graphs? During data analysis, to explore and interpret the results, our methodology section as well, the discussion section, the results section, and in our publications, especially our posters. So when we have posters as well, I think most people would have either done posters or will be doing posters for conferences. The images and how they appear makes a difference as to whether people will also be attracted to your poster, they'll come and ask you questions or not. So being able to communicate what you're trying to say in those images does then make a difference. Where are these graphs or multimedia used? So in journals, in our theses, in presentations, online platforms, funding agencies, and policy briefings. The one thing I actually also was reminded of is, as I moved from being a student to being a staff, every time you have to apply for funding, those Gantt charts are what we actually use quite a lot, especially because for us, people who are in the harder sciences, sometimes it's just easier to explain even to a non-science person what you're doing using graphs. So the graphs do make such a big difference in how you communicate your results, and they actually then help you to get funding even quicker without even you saying too many words. So why are graphs or multimedia important? Basically, they reveal a relationship or ideas that are not evident from the text sometimes. So sometimes you have to use those images, just like I said with those phthalocyanine isomers that I was isolating. The text was saying a lot. Yes, I have the isomers, I can name them, I can put a whole lot of things, but the image itself was the actual determining factor of that evidence. So the relationship I was trying to create between myself and other people was that this is what I've created, therefore I've used an image to show that. And in terms of the benefits of data visualization, we're simplifying, we're engaging people around us, You've shown those trends the credibility as well, and it helps people to make a decision and see that story that you're telling. Dr. Ella spoke a lot about the narrative story that we can tell, so that also forms part of what we can then use. How are graphs or multimedia presented? So there's various softwares that we use. We use Excel most of the time, MATLAB, Python, Origin, ChemDraw, Mercury, ECLab, etc., ImageJ. And I highlighted the ECLab because, for example, with the HER people who are doing that application, they use LSV plots, right? We all see them, they have the value there, etc. Even with dye-sensitized solar cell application, an LSV plot is used. However, what you'll see is that it's represented differently. So it's also quite important for us to understand what analysis we're doing and its relationship, because every time an HER person speaks, they'll be like, yeah, LSV plots, and you're like, even me as a dye-sensitized solar cell person, I use LSV plots, but then we plot them as TOEFL plots. So being able to understand the graph that you have to plot also helps in how you present it as well. Another thing that these graphs do is help us to keep track of clearly labeling our graphs, the legends, titles, etc. The format is also very important. Like I say, you can have two LSV plots, but they're actually telling a different story as well. The relevance of those as well comes into question because it then has to align with your application, and the ethics that we spoke about. Prof. Neil mentioned a lot about the ethics. We also don't need to alter any of our images or any of our graphs in order to suit what we want, but we need to present the data ethically so that we know we are presenting something that is true. So like I was speaking with the different LSV plots, the HER guys, they would generally plot something like that, but the dye-sensitized solar cell guys, they would plot their LSV plots in this way. They are still the same type of analytical technique, but they're represented differently based on the setup as well that we have. So the dye-sensitized solar cell, it's a symmetrical cell that is put out in order to get something like this. But with the HER, I think they do the 3 electrode system still, and they still get their LSV plots. And at the end of the day, different information is being communicated. So I've uploaded on the Google Drive some data points that I'd like you guys to actually use for us to go further into graph plotting, because that's all I'll be doing today, for us to get into the habit of plotting our data.